Hello, this is our video assignment for CZ1012 Engineering Mathematics 2. In this video, we will be sharing on Shamir's secret sharing algorithm. The details of the reference paper is as shown. To start off, let's talk briefly about Shamir's secret sharing algorithm. This is created by Shamir. It divides a secret into parts, giving each individual a different piece of the secret. The secret can only be known if some of the parts or all of them are presented together. To reconstruct the secret, let's look at it from a mathematical point of view. Given the x and y coordinates, how many straight lines can you draw that passes through this point? There will be an infinite amount of straight lines that can pass through this point. Each of the lines have a different gradient as well as a different value of y when x is 0. So, what happens if we introduce a second point, x coordinate 3 and y coordinate 2? With the addition of a new set of coordinates, there can only be one possible straight line that passes through both points. Assume that we intend to use the value of f0, which is 8, as the secret for this line. With only one set of xy coordinates, it is impossible for anyone to realize that f0 is 8. However, it is possible to know that 8 is the secret if another set of xy coordinate is given. So far, we have noticed that, from one set of coordinate, there can be infinite lines passing through it. Yet, the moment we add another set of coordinates, we will only be able to derive only one straight line that passes through both coordinates. Hence, if we have a secret value and store it as f0, and if our function is a linear equation, for anyone to know our secret value, he has to know at least two coordinates on our linear function. The same can be applied for quadratic curves. Given two sets of coordinates, how many quadratic curves can there be? Likewise, there will obviously be infinite curves that can be drawn. And for each curve, there will be a different value at f0. It will be impossible to know that f0 is any particular number. Once again, let's consolidate our observations. For a specific quadratic curve, we must have at least three sets of coordinates. Given only two sets of coordinates, there can be infinite quadratic curves. For a straight line, y equals mx plus c, we need two sets of coordinates. For a quadratic curve, y equals x squared plus bx plus c, we need three sets of coordinates. If we want a secret where a minimal of n coordinates must be known, we need to have y as a function of x, where the function is a polynomial of x with at least a degree of n1. With that, we will be able to split the secret value into multiple portions and only at least n of them are known for the secret value to be derived. So, let's go back to how Shamir's secret algorithm allows group sharing of secrets. Let's do a case study. Suppose that Rudy has a secret value of 4, and that he wants to share with 5 other people. And he wants to ensure that there must be a minimum of 3 people before the secret value 4 is revealed. How can he do it with Shamir's secret algorithm? As he needs at least 3 shares to reconstruct the secret, a polynomial of degree 2 is required. And hence, he needs to generate a quadratic function where f0 is equals to 4. After that, he then distributes some random coordinates on the curve to the 5 other people. After that, as long as any 3 coordinates are presented together, the other members will be able to access Rudy's secret value of 4. Some possible combinations are shown, and thus, in this video, we have shown how mathematics can be applied to solve a cryptographic challenge that we face. By applying polynomial functions, we can break a secret into as many components as we need it to be. This video is jointly produced by the following students. Thank you.